Good morning, kiddos. Today we're going to be working from this book right here, Forces of Motion. We're not going to be in the teacher-made packet. We're going to be right here. Please turn to page 8 in this book. Today we're going to be analyzing the impact of gravity, friction, and magnetism on motion. A force is a push or pull that often changes the motion of an object. What is motion? Motion is the action of moving or being moved. Change in position over time. Please remember that you may pause the video at any time if I'm moving too fast. So how do you move each day? We may move from one seat to another right now, from the living room to the kitchen, but we're moving because of the forces, the push and pulls on our bodies. Remember, our muscles can only pull. They can never push. They only pull, and they pull by contracting. It gets shorter for it to contract. If some force acts on an object, it will cause the object to move. There are three factors that influence an object's motion or change in position. The mass of the object. The greater the mass, the harder it is to move. Example, wind blows a feather easier than a brick. The more mass, remember, mass is not weight. Mass is the amount of stuff inside of an object. Mass might be such as you have a ping pong ball. One is filled with air, and then you have a similar sized golf ball. And that golf ball is going to have more mass to it than the ping pong ball will. The strength of the force also affects motion. Stronger forces move objects a longer distance. Example, a strong wind will move an object farther. The direction of the force also affects motion. A force applied or given from a different direction may change the direction of the object. Think about like when you play soccer. The example given in the book is wind may blow an object in another direction. So think about when you're playing soccer and the ball is rolling toward you, and you apply a force with your foot that sends the ball moving in a different direction. Someone else kicks the ball, and once again, a force is applied and it will send the ball in another direction. How can we measure motion? By measuring the distance traveled. Measurements of length include millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. Remember, these are all in the metric system, and this is where using the graphic organizer that we used, King Henry died unusually drinking chocolate milk, will come in handy for understanding which is greater and less and how they convert back and forth. Remember that a meter is your basic unit, and that when you get down or go up into these, it gets larger. So this is the same as 10 meters. This is 100 meters. This is 1,000 meters. Remember, it increases by 10. These three get smaller. So this is a meter that's cut into 10 pieces, and 1/10 of a meter is called a decimeter. Then you have a centimeter, and this is a meter cut into 100 pieces, and this is one piece. This is about the width of your pinky nail. And then you have a millimeter. A millimeter is cut into 1,000 pieces, and this is 1,000th of that meter is a millimeter. So it's very tiny. Imagine a lot of times the earrings that someone may wear that's the little tiny balls, those are measured in millimeters. Sometimes I will wear a pair that is about the size of a small pearl, and those are about 8 millimeters. So that would be the width of that pearl would be 8 millimeters. There are many types of forces in nature, each acting on objects in different ways. How might gravity, friction, and magnetism impact the motion of objects? So how might gravity, friction, and magnetism impact the motion of objects? Well, gravity is going to keep it pulled to the earth, and then when friction occurs, now you can rub your hands together and it moves pretty smooth. What if we put sandpaper on one hand and you tried to rub it over the sandpaper? Well, yes, it's going to hurt, but it's also going to prevent you from moving as fast. Now, imagine that you're holding magnets in your hands and you go to try to move them, slide them over each other, but they're going to stick. They're going to hold it in place. So it's going to affect it differently. If it's two very weak magnets, then it may slow it down instead of completely stopping it, stopping the motion. Gravity, a force that attracts two objects together. It occurs because of the mass of the objects. So this is like the moon having gravity, has a very little gravity. It's about 1/10 of that of the earth. And then you have the gravity of the earth that holds us to the earth. It pulls us to the earth. And then it holds the moon in orbit in its place as well. So the example is exactly what I just said. It's about Earth's strong gravitational pull. And then we have friction. This is a force that occurs when two objects rub against each other, slowing their motion. Pushing against a heavy door, brakes on a car, rubbing sandpaper over wood to get little small pieces of splinters off of the wood. There are many examples of friction. Remember when we went to NASCAR Hall of Fame and they talked about the brakes? Now, one thing I want to stress here is that remember when we were at NASCAR Hall of Fame, we talked about the aerodynamics of the cars, how they had changed over the years so that they have gotten faster, that they operate better, they move smoother. And this is because they were able to reduce air resistance. Air resistance is also a form of friction. Air resistance will slow a vehicle down. This is like when you have someone with a parachute jumping out of an airplane. What slows them down and makes a safe landing for them would be the air friction. It's called up under the parachute so that the person can be gently pulled toward the ground rather than a quick thump. And also remember, friction produces heat. I would make that note on here as well. Remember that you can always go onto YouTube and look at NASCAR brakes during a race. They will often have cameras underneath the cars so that when the driver applies the brakes get really red because of the heat produced and they will glow. It's pretty cool to see. And then we have magnetism. This is attractive forces coming together and repulsive forces. This is pushing apart between objects. So attractive pulls together and repulsive pushes apart. I can hear some of you now talking about how the attractive forces would be between maybe when you're making googly eyes at some little girl or boy that you like. And repulsive forces would be like when you see someone that you don't like and you don't want to be around them. You find that situation repulsive. So that's a way that you can kind of remember what these two are. Attractive means that you want to be near that person, and repulsive means you want to get far away from them. The example, iron is a strong magnetic metal. Remember that there are several types of metals that magnets attract to, but there are also many others that they don't attract to. And then we have Earth's magnetic field results in two poles. This is because in the center of the Earth, you have the soft liquid center with the core in it and with it spinning around. It has created these two poles. These two poles will shift slightly so that because of the liquid inside of the earth moving. And then we have note, there are other forces at work, but we will be observing demonstrations related to gravity, friction, and changes in mass. How do you think this rolling ball is experiencing gravity or even friction? So how would it experience gravity? It is being pulled toward the earth, and as it's being pulled toward the earth, it wants to go to its lowest point. So the lowest point would be, for example, right here, and then this is even on out through here. So it would continue to roll until the friction that it's experiencing by rolling on the ground, because it doesn't matter how slick a surface is, there's still yet going to be some friction with it because it's being pulled down. So it's going to be rolling over this and it's still going to have some friction there. And does it impact its motion? Well, certainly it impacts its motion. The further it rolls is the slower it goes. And that is the end of today's lesson. I can't wait to see you.